let's grab some Raspberry Pis and have fun with Java on embedded devices.
Welcome to the FooJ Podcast, all your news about OpenJDK.
When you're a backend developer, you may not realize that Java was originally born on embedded devices like set-top boxes and gateways. There even have been specific versions of Java for embedded devices, but nowadays, with processors becoming more and more powerful, we can run the exact same Java runtime on any Linux system, from the biggest cloud servers to the smallest Raspberry Pi Zero. Let's find out what can be done with Java in the embedded world. My first guest is Robert from Burg. How do you use Java and embedded devices?
Well, in our case, in our company, we use them in our medical cabinets. So that means we want to be able to have medical devices, medical cabinets, where we store drugs in a hospital on the wards, where nurses then take the drugs out. We want to store them electronically secure so that we can measure when and what is taken out of a cabinet. And for this, we use the Raspberry Pi's I2C bus and the one or other GPIO. And this is always done in a way that the nurses never see anything of it. It's a server-based software. The cabinets are connected through a Java application that is running there with WebSockets to the server. And so we use the Pi4j library, and we try to keep this simple as possible, but still use the full potential of the Raspberry Pi.
My next guest is Pavel Petroshenko. What is your history in Java?
I just realized I've been in the world of Java and embedded devices for almost 20 years already. So I started working at Sun Microsystems as a part of Java ME team back then. That was the Java platform for embedded devices and mobile phones primarily. Then that platform evolved into a platform for embedded devices that was Java ME embedded platform, primarily focusing on appliances and other small embedded devices, essentially, that were not capable of running modern, by that time, OSs like Windows, Linuxes, and etc. That was real-time OSs where that could fit only small runtimes. And then after several startups, I joined Azul, where I lead Platform Core, which is a distribution of OpenJDK. I lead product management for Platform Core.
And my third guest is DaShaun Carter. Welcome.
Hi, my name is DaShaun. I'm a Spring developer advocate. I started using Java in university. I think it was in 1997. And then again in 1998. I think it was right around the 1.2 release. And Java was, I remember the book and the story was like, yeah, Java's that thing. It's going to be able to run everywhere. And they said it's going to run on your toaster and it's going to run on your refrigerator. It's going to run everywhere. It's amazing. And just the conversation, it was exciting. But my university was kind of at the front. They were teaching it at university, and I'm very thankful that they did. I've been using Java as kind of a core on my career since the 90s. And now I'm a Spring developer advocate, and I'm passionate about Raspberry Pis. And I work with customers that are using Raspberry Pis or similar devices all over the place, from oil tankers to water treatment facilities to their how they handle luggage and on their production floors, in their factories and manufacturing. So I have fun with the release of Spring Framework 6 and Spring Boot 3.0. I got really, really excited because now we can actually take my Spring Boot and those kind of workloads, and I can deliver them to these small, affordable computers and do lots of really interesting things. So thanks for having me on the show. I'm jazzed to be here.
With pleasure. And I'm Frank. I'm doing Java development for over 10 years. I started experimenting with Java on the Raspberry Pi over 4 years ago. There's even a book I wrote about it. And it eventually landed me a job at Azul. So now a colleague of Pavel. Yes, so Java on embedded, I'm happy to hear from you, DaShaun, that it's running on so many environments. Robert is running it on medical cabinets. So I guess we can say that although people know Java as the system running on big servers in the cloud, on your desktop machine, but there is more Java out there than we realize, I think.
I agree 100%. One of the interesting things about being in this role is getting to talk to customers all over the globe and hearing their unique use cases for where they're using it. And sometimes, right, the default, it used to be that, oh, computers are cheap and we've got a data center and disk is cheap and all those things. Well, now those pennies that you save for that thing that might be just controlling a medical cabinet, right? It doesn't need to be a data center rack and have, 15 levels of backup and redundancy. Maybe what you need is something that is small and affordable and can be easily replaced. So these use cases and these different vectors that we have to decide where we're going to run our workloads, those have now become a differentiator. Those have become a critical component of how our business survives, because we know that survival isn't mandatory. And it's these little changes that we can make that might make the difference.
Mm-hmm. Pavel, so you mentioned you have a long history in Sun Oracle in the Java development, actually. So you were part of the team that developed that Java micro edition. How was it different to the OpenJDK or the Java runtime that we use on our PC?
So I think it makes sense for us to dive into the history and remind ourselves what these devices looked like back then. Now we are used to all these modern Apple devices, Google devices, and other vendors' devices, which run full-fledged operating system with native application model with app stores and application marketplaces, etc. Back then, there was like these dumb devices that could just call, that had like physical buttons, really small screens, like 32 by 48 pixel screens, with really limited capabilities. Initially, it was probably just calculator. And as devices evolved, there was a demand for having something else on top of that. Like first thing was games for sure. And if you think about what needs to be done in order to deliver gaming, like custom games, not pre-installed games, because there were tons of pre-installed games like Worms and snakes, cards, etc. That we all know very well. So people needed to install something on top. So essentially what's needed was some platform that would deliver connectivity, security, application management, some multimedia capabilities, and all that. And that's where this demand and that's where this Java platform came with. If you think about these devices, they only had in the best case, hundreds of kilobytes of RAM compared to gigabytes today, and only megabytes of storage space where you could install something and where applications could dump their intermediate data, etc., etc. And that's what JavaME, if I'm not mistaken, JavaME was announced in 1999 as a platform by Sun Microsystems. The way it worked, it was a replacement for an operating system. It was playing a role of an operating system. It managed applications, managed processes, managed resources, connections, etc., like everything. And that's where Sun Microsystems made this great step to standardize it so that all the vendors can start implementing and installing and using these Java platforms and start providing ways to run Java applications. And that was one of the game changers back then. So you could now download your own applications. You could run some custom things, and you could even implement some basic applications and run them on your phone. I remember when running my first Java application on my phone, that was very different feeling, like that.
It was like I remember. So first of all, I'm gonna say thank you. In 1999, I think that I had my first generation phone, and I was moving into the real world. I was moving into the .com boom, is what we called it in the US, where like everything is going to the web and everybody's doing all these things. And I found myself consulting and needing to upgrade my phone, right? So I went out and I was like, well, of course I wanted to run Java. And I remember finding, and I think it was a Nokia phone that was running Java ME. And I remember thinking, oh, well, now I have this phone. Now I got to build something on it. And remember, we only had like 12 characters across or something like that, and like 4 lines of text. So there wasn't much there. But the idea was, hey, I wanted a front end system. I wanted the thing for the people that were working in the retail side of the store to be able to call back to storage, to the pick and pack back end, something that they could do on their phone. Like, I need one of product A9. So it was just kind of the code ended up being, there was a format for it. We're like, hey, we have different pages of views, but it was very similar to the stuff I was writing with batch files back in the early 90s on my PC. It was just like, hey, here's the screen, here's the menu. I had a select and then OK and return. But my mind was still blown that I had all of this amazing, cool little power on my tiny little Nokia phone. And yeah, I'd already bought into Java at that point, but that just kind of like solidified the value and the roadmap that was set for Java. That it was really, it was going to go places where we didn't think that we could go as easily as we could. Java opened the door to a lot of different things, and that's just one of them.
And it's not only that Nokia phone, but we found a video of this Jasper S20, which shows a UI where you can scroll through. I just watched the video through pictures. Like, how was this even possible at that time? With I lately heard the comparison that nowadays a phone has 100 times the power that was needed to put the first man on the moon. The whole computer system at that time, now a phone is 100,000 times more powerful. But if you go back to 90s, how was it achieved to now the Java that we have, which is, if you install Java, is now 200, 300 megabytes? What happened in between, or what was so special of that version of Java that it could run on such a small device?
Yeah, and if you also remember about the battery life of those phones back then, it was days, sometimes weeks, right? So there are several reasons why Java was a success. One of them is security. Java was designed to be focused on security in terms of end-to-end security, server to edge device connectivity. It implemented the latest standards of encryption, etc., etc. Also, robustness and security from developer point of view. At that times, C, C++, assembly were the most popular languages. And if you start thinking about the major problems of those languages, it's resource management, memory management primarily. You could write, you could read from almost everywhere, which results in blue screens, which is unacceptable in the mobile world, right? Because it crashes, it impacts your applications. By the way, so another thing which I just recalled, it's multi-processing, meaning that you could run multiple applications simultaneously, even though like physically it was one single native process, but at the application level, that was considered to be multi-threaded environment already, and you could run multiple applications that preempted and allowed for execution of parallel user threads and the system threads that managed all the connectivity and all the system stuff. Application portability, that was the main the main thing. You write it once and you run it everywhere. You run it on your fridge, you run it on your printer and on your mobile device, which never happened. That was a myth. But for a number of reasons, and we can dive deep into that. Application size. So Java bytecode, if you think, is almost an order of magnitude smaller than native code. And back then, when we had really slow connectivities and speeds of these wireless networks, that was critical. 7 times, approximately the ratio, I think, of bytecode to the native compiled code is approximately seven times. And at the final application management, no other platforms had this way to auto-update applications, manage sources of applications, launch them, et cetera, manage multiple applications running at the same time, et cetera. That was all new. So that's what all this was proposed to this world. And a lot of this was different from what Java had in the desktops and server platforms.
Let me take a big jump. So we are now on those old systems. Now, if we go to nowadays Raspberry Pis and other equal boards like BeagleBone boards and stuff like that, they are really powerful. They have the latest ARM processors. They have 2, 4, 8 gigs of memory. And I think that's also how you use them, Robert. They have these extra physical pins that allow you to interact with sensors, with output devices. Is that maybe the biggest advantage of why you use these Raspberry Pis, for instance?
Let me back up to a bit of a history part. I mean, you guys were talking about all these embedded devices, and I started my Java career in a different segment. It was server based, but it was already, we are doing real-time solution platform for shop floor logistics. So there were PLCs from Siemens that did all the hardcore time management of conveyors, etc. But they still needed some higher level application for managing which box goes where. And this is where I came from and where I started my career. And that was really interesting, because if you talk with other people, especially those days when I was still at school and stuff, then people say, but Java's too slow for that kind of stuff, for this business processing, especially in the situation where people really stayed in their old days of everything needs to be in a relational database. We already then, in those days, we were completely in memory only. So we would just read the whole database out into memory at startup, and then keep all decisions in memory, which would allow us to be really quickly to decide which box needs to go where. And it was way more powerful than actually needed in a Java-based system where we had high security, we didn't have memory problems, we didn't have out-of-bounds exceptions, all that stuff that was plagued in a C++ environment. And that's what we loved. We could just really get down to business. And well, that's where I started off. But yes, now today, so what I said before is in medical cabinets, we use the Raspberry Pi for the I2C bus. But we also do something completely different, where we actually have gone so far as to build our own PLC on the Raspberry Pi. That means we've bought some very simple I/O expansion boards that we then also use through I2C, and we can now do the complete thing we did, which used to be Siemens PLCs costing a fortune. We can now do on a Raspberry Pi with native Java code, writing in the same language on the server as in the PLC, and keeping us really focused on what we want to do. And this has really allowed us to then, control conveyors real-time based. Well, I mean, real-time in a soft thing. It's not a real-time, but it's more than adequate. And our customers are really happy with what we offer in this situation. And that's something that really gives us a great value for in Java and with the Raspberry Pi. So you have commodity hardware doing really enterprise grade applications. We have easily replaceable components when it needs to be, but actually Raspberry Pi is so stable and so well built that they never break anyway, unless you do really weird stuff. So yeah, that's really an interesting part, and what we really love is to be able to stay in our language, use the same domain specific languages, and then you can really stay keep work going on without switching languages or whatever, and write once, run anywhere. It still applies to today.
Yeah, there's a few things there that you touched on. The ease of access to commodity parts, components, right? They weren't always designed for Raspberry Pis, but now you can see that Raspberry Pi is kind of influenced. You're finding more hats that are built to fit Raspberry Pis, and competitive boards that are built to fit where Raspberry Pis fit. Also, in my journey, I noticed when Raspberry Pi started offering commercial support, I think this is in 2020 when it became official. Like they had a fully commercial licensed approach. So like, hey, yeah, this is the customers that are going to get that access. When supply chains have issues, this is how you can get that commercial access, so you can actually build your business on top of this Raspberry Pi platform. So that was the first thing that definitely has changed. The other thing that you talked about is Java being able to now command and interface with all of these other things. That was a big shift. And I've worked with customers that were like, yeah, we were using these other boards, these other components, and we were having to do this other language, this other approach. And yeah, when person leaves, all of that goes with them. Now that we can use Java for our ERP systems and all of our e-commerce systems, and I can use that same expertise to control these devices that we're putting out into the world at our customer sites. This has completely changed the game for some of these customers that I've been working with. They have the ability to kind of raise the entire organization by their investments in Java and the Java ecosystem, because they're using it across their entire organization, and they get those benefits.
Especially when you think about also being a web-based applications, even the PLC, we write a simple web-based UI to look at all the controls and to do maintenance and diagnosis, etc. And the same stack is on the server for the ERP-based web solution, and that really makes it so much easier to onboard new developers.
Is the title of this podcast episode maybe wrong? Are these really embedded devices, this Raspberry Pi?
Good question. Yeah.
It depends on where you put them, right?
Yeah.
It depends on where you put them.
I have a colleague who probably debate it and say this is not an embedded system, but then again,
they have become so powerful that they are actual PCs.
Well, they're more powerful than the PCs that I was learning on, right? Like what my kids have is, hands down, it's more powerful than what I was learning. I was doing really interesting things. I was hosting websites on 1U commodity servers, and today, if I were to do it again, I could have I could replace all of those servers that I had in 2008. Those one CPU, 1U servers. I could replace all those with Raspberry Pis, and I would be fine. My infrastructure would be just fine. I could literally do a 1-for-1 replacement, and things would maybe even perform better at this point. So that has changed. But now the other interesting thing is like, hey, are they embedded? We can put these devices into really unique situations that we couldn't do with a 1U server with the commodity hardware desktop level or data center grade equipment. These devices are going into interesting places, and they are becoming a part of bigger systems on vehicles, on control towers, of manufacturing floors. And this medical cabinet case where it is kind of that one component, and then you kind of describe there's another part of the system that is keeping track of those. I want to know more about that, but is it embedded? Yes, I think it is, and I think that the definitions, we can argue about definitions. We could do that all day, but it's interesting in that it changes the paradigm of where we normally see Java going, right? Java's been around for a long time. And when we think about it, the other, I guess, part was like the real time, the speed and performance of having everything in memory. Those were massive advantages. Again, my background coming into the .com boom, hearing about what Azul was doing with the JVM and how much memory they were able to provide to the JVM, those types of systems that needed that speed, the millisecond latency, and they were able to do it within the JVM, that was a differentiator. especially in the financial services, that it just changed the game. And knowing that, hey, there's a possibility, it changed the way people were thinking about their systems, and they didn't have to worry about the arrays running out of memory and having to do all that collection. They could focus on their core logic. They could focus on the differentiated aspects of their business, and they could go fast.
So we had this Java ME, which was focused on these small devices, which was correct at that time. Do we see now that we have these more powerful boards, that we can just use the same runtime that we're using on our PC can just as well run on these boards? That's right.
And I think that's what Robert mentioned. So one of the key driver for Java there on these devices, not only on these devices, on the embedded devices today, is the platform and code unification. If you have to support multiple hardware platforms, I can imagine having medical cabinets, having multiple revisions, and they could evolve from 32-bit platforms to whatever, like latest revisions of Raspberry Pi hardware, which is like pretty comparable with some server side hardware. And you still want to maintain the seamless your source base, which runs everywhere, like across all these devices, meaning the same level of Java version, the same level of features available to customers and users. I think Java is one of the solutions there, because it's available across all this range of devices there.
Yeah, in our case with the medical cabinets, I mean, we pretty soon decided on the Raspberry Pi. We did do first experiments or the thought proof of concepts with the BeagleBone Black, or what it was called back then. Somehow we landed with the Raspberry Pi. I think it had a bit more to do with the community being a bit better at the time, getting quicker onboarding and running a Java application. And that is a big part of everything. I mean, the Raspberry Pi community is phenomenal. The amount of documentation that's out there has just gotten better and better, and which is why we've always been on the Raspberry Pi. But we did start out on the 32-bit OS. And then we moved to the 64-bit version quite soon, as we just wanted to stay on the same version as on the server, as we saw that it didn't really matter, and the Raspberry Pi actually offered, or the JVM 64-bit offered a better performance with the 64-bit than the 32-bit JVM, and that was that actually led to some race conditions with the ICT I2C bus, which we had some bugs that we had to iron out. But so it was still the same codes and just a bit of testing, and then we saw that everything just worked fine. And that's always been the case now with all the updates from the Raspberry 3, 4, and now the 5, where, well, we need some new drivers on the Pi 4J side, but otherwise everything just works.
Mm-hmm. Out of my curiosity, did you guys, when you've chosen the hardware platform for these devices, what other languages, technologies did you consider, and why did you end up using Java?
Basically, there was never a question of using a different language than Java, as our server side was always Java, and we knew that it was possible to run Java on such a device. Especially when we looked at the time when we started building our cabinets, there were already a few such devices coming out where you could run a normal Linux system, and the JVM was available thanks to the ARM 32-bit architecture. Mm-hmm. So this was why we quickly didn't even think about using a different language, and we also knew that we just wanted to actually communicate with the server with WebSockets. In this case, now is what we decided, and we wanted to use the I2C bus, as in our case, this was the bus that we decided was the most efficient for our solutions. We could have used any other bus, of course, SPI or serial interfaces, but we did have PCBs that we designed ourselves, and in this case, our electronics developer decided that this was the way to go. And as we saw that we could communicate thanks to the wiring Pi and the beginnings of the Pi4J status, we could use this. We decided that that was the way to go, as again the community was there.
Without maybe exposing brand names that you cannot name, but I know that Java is running in a lot of devices that people don't expect. I know that there are a few Java licenses in my car here in front of the door because it's used in the infotainment system, for instance. Are there other unexpected use cases you can talk about? You already mentioned ships, I think, DaShaun.
Things that I can say on the boards wise, the boards Raspberry Pi kind of like started it, and then you found these other boards that were kind of custom built or purpose built. Like some boards had better video processing, some board had more USB ports. You were running into limitations on your use cases. So we saw like, hey, there's some room in the market to build a competitive board, similar processor, similar. Hey, I can use the similar operating system, and I can. It's worth it for my business to go in that direction. But then the ability of Java to be able to move across these different platforms with relative ease, I saw it in the Raspberry Pi first, and then when we started seeing ARM64 being available in the cloud, then because it was Java, the Java workloads were the first ones that were able to switch or run side by side and say, hey, you know what? Hey, this ARM64 single thread per core approach, it actually works better. Not only was I saving a boatload of money by switching the architecture, I was finding out that the way that my system works, I was actually performing better on that ARM64 architecture for reasons. Again, it's another one of those vectors where we get to decide, whether I want hyper-threading is going to perform better for this workload, or that single thread per core is going to work better for this workload. But now I have a decision, and I can use Java, and I can switch back and forth. I can do the experiment, and I can decide, do I want to save $1 million this year? And it's as easy as that. A lot of the other languages, frameworks, they didn't have that ability to make those types of moves. So the promise came in the 90s, write once, run anywhere. And now we're seeing it really in fruition across platforms, across clouds, across different types of infrastructure, where we can make a decision based on the market, based on our workload. The right answer changes over time, and Java allows us to change over time without changing our language.
That's actually a point I was not considering. So am I right to say that Java on ARM was first there on embedded and then came to the Mac, came to the cloud?
Yeah.
Okay.
Right. So
Indeed.
I started working on this build pack that I was doing it for my Raspberry Pi workloads. We had the ability with GraalVM to do the native image that I could run on the $15 Raspberry Pi 2. It had the 4-core ARM64, and that was exciting. But I was doing this as like a project for the stuff that my kids are running in the house, so I could fit these. I'm a Spring Boot guy. I wanted to have the enterprise grade, production ready things that had actuator endpoints, but on these $15 devices. That was the goal, and I was able to do it. I was able to replace the Python projects that I was finding online for all the other Raspberry Pi cool things. I was able to replace those with these Spring and Java on these small devices. But then the M1 came out. I'd been doing this thing for a while. The M1 came out, and then all of a sudden, the community is like, "Hey, your build pack doesn't work on the M1." I was like, "Uh-oh." I wasn't expecting it to go there. I wasn't even thinking about. We had ARM64 in the cloud already. I'm thinking of. I think it was 2021 when the M1 came out, or early 2022. And now that I have these build packs that are working with. At that time, it's called Spring Native. And I had a community that was starting like, hey, we need that too. Can you give us the new release? We want the latest Java version. Can you help us? And it became important. That change became important. And then even a friend called up and said, hey, can we use that build pack with Zulu? Yes. And this is, where we are. It definitely started on the Raspberry Pis for me. And then the cloud came, the cloud Ampere VMs that were available. And then came the M1s. So what a journey.
And I'm going to add a link to the show notes of this podcast to a presentation of Miro Wegner. He compared the energy efficiency of Java versus Python and other languages, where it shows that Java is way more energy efficient. And the same goes for the processor. The ARM processor is way more energy efficient than other processors. So that's nowadays also a very hot topic.
I heard
It's
that the topic of green computing, like when we start talking about the native images, but even just ARM64, I always say like running on ARM64, it's like driving a Tesla. It's just better for the environment. Like, hey, it's the thing. You make that change. If you can make the adjustment, there's business reasons to do it, but if you can make the adjustment, you're saving the environment. I replaced my data center, right, where I had a lot of racks like sitting behind Robert. I had a few of those under the stairs in my basement, and it was running at 1.5 kilowatt hours at idle. Like just having my racks turned on, 1.5 kilowatt hours, and I was like, "Oh, this is crazy." So fast forward, I replaced all those racks. I've got quite a few of these Raspberry Pis, but I can do really interesting things with those. I can have them sleep. I can send a signal to the Pi Sugar that says, "Hey, I want you to wake up this device, get some data from it, and then I want you to sleep for 5 hours." So I've got a lot of flexibility, and these things are consuming a fraction, right? Even the hundreds of them that are deployed in my house, they're still consuming a fraction of what my one rack of Dell R710s was consuming.
And you are pointing out that it's the green factor, green computing, but actually, if you do this, you also save money. So
Yes.
it is good for your business.
Absolutely.
You have less energy. Devices as such are also cheaper, I think. So in the end, it's also a business advances that you make there.
Yeah. So the presentation that you're referring to, I know that there was a new stack blog post that kind of ranked all the languages, and it was like C and C++ for up the top, and then it was Java. Like it was like 2 times or half the efficiency of C, and then like at 18 was Python, and like TypeScript was way down. Like, but it had these rankings. But that blog post came out in like 2018 that we can do Java on the JVM today. I'm curious with all the other advancements that have happened in the Java ecosystem, especially around the JVM. I'm wondering what that would look like today. I'm very curious to see what that relationship will. I guarantee it's closer because of all the advancements in the JVM.
Which is a good topic to come back to. So indeed, Java is evolving. Every 6 months we have a new version. Within these versions of the last years, did things change that have an impact on how Java runs on smaller computers?
Virtual threads. Yep. Java 21 virtual threads absolutely changed the performance metrics. That's a blog post in itself. Like I can take some of these toy projects that we're running on, we'll say the $15 Raspberry Pi 02 as the baseline, and there's this that XZ hack that happened a little while ago. It was somebody that was like, "Oh, that command, there was a tiny little, it felt like it took a little bit longer. Like, what's going on?" After they did the update. And that's how it was identified. And when you're doing things and you see it long enough, you expect like, oh, here's the timing. So I didn't measure, but that timing of the things as they started up and as they were running on these little devices, I absolutely noticed that. How much snappier it was when I enabled virtual threads and I put these on these small embedded devices. It was, to me as a person, it was visibly noticeable.
Pavel, you're really involved in the whole development of Java, the language and the runtime. Do you see finished projects, but also upcoming projects, which will have an impact on how Java is used on embedded and small computers?
Before we answer this question, we should probably define what these small and embedded devices and computers are. One of the things that I personally see, and that may be a separate project, is support, like full-fledged support for 32-bit configurations in Java 21 plus. because out of the box there is no support for example, for ARM32 in OpenJDK. That's something to build this. Vendors need to do some changes, and that's probably one of the project. One of the key.
And what would be the advantage of going back to 32-bit?
It's not that we are going back to 32-bit. It's that we clearly see a need for people to upgrade their Java requirements to have similar source base, similar level of supported features, even though they don't necessarily use all these new fancy sexy features on these small embedded devices. But the fact that they have to maintain only one source base is a big deal for some customers. And the use case could be anything like from infotainment to whatever, like terminals, and banking terminals, or vending machines or stuff like that. So that's what people. That's a typical use of Java that we see. They just need to run it like across their fleet of devices. Otherwise, they have to pay separate teams to maintain and evolve these source bases, which is way more expensive for them to just upgrade it once and then keep it alive. Yeah, that's I think the major thing that I have on top of my mind. In general, I think there will always be a space for these small embedded devices. However, as we get more and more powerful devices, I think more and more standard Java distributions will just run this embedded use cases. One thing to mention, and that's what probably I had a question to you guys. So the limitation today for all the Java and all these embedded use cases is non-real-time use case. And DaShaun, you mentioned real-time processing earlier today. By non-real-time, I mean everything like infotainment. It could be some infotainment in the cars. It could be infotainment even on the planes. We've seen Java used on the planes without going out in specific vendor names. But did you guys have any experience with hard real-time requirements when there is certain response time requirements that you had to meet in your applications in embedded use cases where you had to use Java, and how you work this wrong?
I have one fun example, and that's controlling LED strips, which is a challenge in Java. And
that's very true.
That's the only use case I go back to a microcontroller, because it really needs strict timing. That's the only time I found it difficult and something was not achievable. There are also a few sensors like the one-wire temperature sensors. These are very hard to read out with Java, but I don't know if these are real use cases for Java on embedded. So maybe Robert, DaShaun, you have more experience with these kinds of requirements.
So what I can certainly say is that for our Py4J library, we definitely always have the problem that some devices, they really do need a real-time communication with them. So they really expect a packet to arrive in a certain amount of time over whatever interface it is. And I mean, we've seen this now, as you said, with the LED strips or temperature. So one-wire communication can be such a situation and everything. This is something that I've also been thinking in my company where I work, where our PLC that we've got, where we can control the conveyor. So we have a sensor that says a box is there, and now we have to close a gate or something, and we have the same situation. In our situation, the Raspberry Pi is fast enough to handle this, where, I don't know, 50 milliseconds is more than enough, and you just add a bit of timing in there, and then usually that's fine. But for something like like a LED strip where the packet needs to come in 50 microseconds, you'll always have a big problem. And there, the question is, of course, not the JVM, but rather the operating system itself, which can guarantee us this hard real time. And there, so I'm sure that, I mean, the Linux kernel is soon going to have the real-time code mainline, so we might have a possibility to do more real-time testing soon without a lot of kernel hacking. Who knows? Maybe our problems will be solved then.
That was the big hurdle for situations that I was in, is like you can do lots of amazing things. Java's fast, but it really was reliant on the operating system that we were running. So the use case that's in my mind is with drones. Like, hey, I'm a Java developer. I want to control these 8 propellers with Java. But in order to do that underlying operating system, it couldn't give you all of the guarantees that you needed for a device like that. Hence, we're using these microcontrollers. So now it's like, hey, can I take my Java bytecode and deliver? And I've been asked this hundreds of times. Like, is there an easy way? When are we going to be able to do Java on a microcontroller? And I know that there's people that have done it and they've done amazing magic. I've not done that demo yet. But yeah, it continues to move forward, and that has been kind of the bottom line, is like that hurdle of the operating system, which I know we're in such a lucky time right now that all of these things are like, oh yeah, that's a limitation. That's going to be a while. And yeah, you stick around long enough, these things get resolved. There are people that are working on those problems, and we get to benefit from them.
You either throw out a little bit more powerful hardware, or you just switch to native for certain real time and sort of hard real time tasks, and then address it this way. Yeah, that makes sense.
I'm always reminded, early 2000s, data centers was a big deal. Like you could make a business just of, I can build a data center faster or better, and I can put in all those requirements that you need for your security, et cetera. And the data centers that were in Wall Street, in order to not give away advantages to anybody that's closer to the network, every computer had the same length of networking cable, whether it was right next to the switch or on the other side of the room. They all had the same length because they couldn't give an advantage to the rack that's right next to the switch versus the other ones. For Wall Street and for the financial industry, that extra fraction of a millisecond was the difference. So unless your facility had that, yeah, we're coming a long way. These are the types of things. Those milliseconds matter. I like to say that latency is the new downtime for a lot of these use cases.
But even that latency that you say for the financial markets, Azul has a solution, because I think the top 10 companies are using it. So yeah, there are differences in what is real time. If you look at trades being happening, that's in milliseconds. If you look at electronics, then it's even faster. And those are, I think, two different use cases. And because all these microcontrollers are also so cheap, I think I solved my Let's Strip challenge with a little serial device that I could control through Java. And that little device is then controlling the electronics, which really needs this strict timing. There are solutions, and nowadays they're all very cheap, luckily, which allows us to experiment a lot. Okay.
I was going to say, one of my customers, their use cases, they're dealing with oil and pumps and switches and all that kind of stuff, and they're measuring it on this cubic millimeter of oil. Like each drop of oil matters, and that's the level of accuracy, millimeters, centimeters, but like ridiculous for oil, that they need to get this level of granularity for their pumps or whatever it is. This is an amazing time, and it's those differences that we can do now that we couldn't do 10 years ago, that those are the ones that are going to make the difference going forward.
So basically, there are certain applications where Java will never be used today, which is self-driving car applications, for example, or avionics on the planes, etc., where hard real time is required. But in most other cases, Java is pretty useful.
DaShaun, you were in Barcelona, I think, a few weeks ago for Spring I/O. You even had a talk there about Spring Boot on the edge. Can you share what your talk was about?
The main point is the number of devices that are being deployed, the IoT devices. I think the metric was like 24 billion by the end of this year are going to be deployed, IoT connected devices. And what I was trying to explain is like Java is running in these devices more than you think. So whether they're in the telephone poles or my kids' rooms, right? The number of devices that are running Java and they're connected, that is definitely trending in this direction. And now we have the ability where we're running Spring Boot on these devices, and we can do it easily. And we have tons of options with the JVM, with the native images, and then also, right, the different types of chips. With Java, I can still run on other processors. If there's a JVM there, right, the next hurdle for me is the Risc-V and running workloads on these similarly affordable devices. Very different architecture, but with Java, I can still go there, right? And as we get that differentiation, there's going to be more and more use cases. We're still kind of, it's still like a new age of all the things that we can do on these little devices, and they're going to be everywhere. So my journey was really just about like, hey, you can do it, and maybe you do have a use case where you could have a differentiator by delivering a small device that might be connected to other small devices, but running Java workloads and giving you all the benefits of Java across your organization and across the globe.
You mentioned Risc-V. What is that? That's a new type of processor?
This is a new type of processor. It's an open source architecture. So ARM there's a consortium behind it. You have to license that their architecture. You have to license it. Risc-V is fully open. So it's not as performant, but because it's open, anybody can go and develop a Risc-V processor. You go print off your own silicon and you're okay. There's no additional licensing. So a $15 computer becomes a $7 computer with a Risc-V processor. So same everything else, but because the licensing for that processor is not included, it becomes more affordable. And soon, we'll see. I don't know if it'll ever make it to the cloud or to the data center, but I also think that there's going to be more workloads being deployed outside of the data center in the traditional the cloud environments. I think there's going to be more workloads being deployed outside of those environments than ever, right? Than the ones that are being deploying to the data centers in the clouds. Mm-hmm. So yeah, it's a trade-off.
And do we already have Java for this Risc-V?
We do. Yeah, we do. And we also have I've not taken it there yet. I've got my stash of Risc-V processors, Raspberry Pi-like boards, and I also have a promise from the GraalVM team that I can deliver native images to these Risc-V. So there's some room there, but yes, we do have versions of Java that are running on these Risc-V boards.
Okay, I need a few more test devices to put on my
test
table there.
Yes. Yep.
Robert, can you give us a bit more detail of the devices that you're building, so these medical cabinets, and how they interact with how people use them and what the software is doing there?
Right. So our cabinets, they are built in a way that it's a standard cabinet. The first version was a wooden cabinet with drawers that had a lock at the back where if someone wanted to open it, they would have to first select the patient for which they want to take something out of the cabinet. They would then select the drugs that a doctor, a physician prescribed. And then they would say, check out, and then the relevant drawers would open. So the total cabinet would be locked before anything could be done. And then when the lock would unlock, an LED on the front of the drawer, the right drawer, would then light up, and the nurses would know in which drawer the drug is that they want to take out. They would then open the drawer. While opening the drawer, the the PCBs inside the drawer would activate an infrared net that would watch all the slots in the drawer. So we would have up to 8 lanes of drawers, which would have plastic insets where the drugs would lie inside. And we would then know virtually which slot is how big. So we would then light up 1, 2, or up to 6 lanes, and when someone put their hand in, then we would with the infrared we would detect the nurse put their hand in which slot. So this would help us to see that the nurse actually put their hand in the right slot, and only then the process would be able to continue. And the other thing is, next to the infrared light, we would also have a normal RGB light so that we could light up the right slot. And this, it was also made in a way, built in a way that we could very easily take out a whole lane of infrared lights and double the size of a slot in the x-axis. The y-axis would always be the same size, and there you could put in little plastic dividers dividing up slots, and then in the software it easily just click it and you'd make a slot larger or smaller, and then this information was always on the server and be pushed down to the cabinet. And what made this very practical is that the cabinet is very simple. It doesn't have any information about patients or drugs or whatever. You would just know, I have these slots, I would have a name on it, whatever that might be interesting for maintenance, but not anything else. And will completely be controlled by the server in real time. So the nurse would, of course, just communicate with the server, and the server would know with which cabinets to communicate. And we then extended this actually to go even further, that we built our cabinets to do this, and these would be fully have electronics and everything, with all the checking of putting the hands in and everything, but would also be able to add simple locks for the already existing cabinets that they might have in a medical ward. So then I could just put in a lock there, so the hospital's in-house people would then go and build in the lock in a way that they would like it. We would just have a cable running to our existing cabinet that we would have there, and then we could have additional electronically locked cabinets. And this allowed a hospital to buy very little or as much hardware as they wanted from us, still use existing stuff, and we could actually fully control the logistics of drugs on a ward. And this is very important, not because we want to see what drugs get stolen and stuff like that, but actually to measure what happens. So first of all, the cabinet would always know how much of a product is in the drawer, because they would say how much to take out. Of course, if they enter the wrong value, then stuff happens. But then again, it's still much better than what they had before, because they wouldn't know where the drug is. They would order often too much, etc., etc. And we always only had the drugs in the cabinet that were really also prescribed by a physician. So people wouldn't have to. People usually would order too many drugs because they didn't know if a physician would prescribe like over the weekend and stuff like that, so they could reduce the amount of stock on a ward. So this is stuff that is the logistics, or is our company's IP. But then again, for the hardware side, it's always been very important to get this working together in a simple, transparent way. And we've now gone further, and we build our own movable cabinets. So these were existing cabinets that we put in a ward, and they don't move anymore. But now we've gone further, and we've actually put them into movable cabinets, which the nurses will take with them to the patient's bed. And now they could do further work. They could actually then take, before they go on tour, they could check, okay, I've got these 5 patients that I'm going to visit today, check their small little cabinet that they're moving around, their trolley. Do I have everything? No, okay. Then communicate with the main cabinet, fill up the trolley, walk to the patient, and thus walk less around, which is a very important fact of nurses. We want to keep them nursing and not running around after administrative stuff. And yeah, so that's one of the further parts we're going. And here we've got the exact same technology, the exact same stack. We built a bit different PCBs because of size constraints, etc. But we're still using the Raspberry Pi. We're still using our same Java code. And now we're just being wirelessly connected to the in-house Wi-Fi. Before we were using Ethernet, but still for the nurses, it's the same situation.
Mhm.
They can still use the same software. They just have a bit additional UIs to handle trolleys and not just awards stock, etc. So
That's the first mention of Wi-Fi. Right? This is another topic, is that these devices, Wi-Fi isn't always within range, right? Being able to access some of these other protocols, the LoRa, for example, where we have kind of different use cases. We don't need the gigabits per second, but we need to get that information. We need to get it, and maybe it's again, I'll use the oil tanker that's 20 kilometers offshore. We have other ways that we can deliver that data. How do we hold on to data? Like if I don't have any connectivity, how do I store that data on a device? And then when the connectivity arrives, then I can send it. Or how do I summarize the important bits of information instead of sending thousands of lines of a log from the system? How do I summarize that information, send a smaller packet in another way? But that whole segment that you just went over, it blows my mind. This is a great example of how we can have these sensors closer to the data, the actual data, and deliver things. It's one of those small changes that we can do so that we're not spending too much, buying too much, letting stuff sit on the shelf. And that goes beyond just medical, right? That goes to all the other industries where we're buying stuff from our supply chain. So thank you for that. That was what I wanted to hear. You got my wheels turning.
There's a picture of those cabinets on the Pi4J website, so I will also add a link to the show notes that you can go take a look.
And I'm happy to give you even more info if you want to DaShaun. I'm always interested in showing.
I'm going to be bugging you now. It's recorded.
It's recorded.
You heard it. He said it.
Watch out with Robert, DaShaun. He built his own version of a spring system, so he has a. He's competing you on that.
I don't use Spring.
That's all right.
But I'm not against it.
Not everyone can be perfect, Robert.
Yes.
No, I also like your solution because it's really. They always say software should be easy. People should just do not need the training to use software. And the same with your cabinet. It's just by opening the right drawer and lights turning green and red that people are guided into that system without having to learn a lot of stuff and those solutions. And with nowadays electronics and the price of these components, building such a prototype is also become very easy and affordable. Maybe a last question to conclude. What will the future bring to Java for embedded or these small computers, or what is the future looking like?
Faster, more secure, smaller, or at least adjustable in size.
The work that's been done in Spring Boot, even though I don't use it, is really good because you get more people be able to actually think about using the JVM for their applications, and having Spring Boot and now with the Pi4J library being integrated into this, you can really get onboard new developers, and new developers will have new ideas and become creative, especially when they come fresh from college or whatever school they've been doing, or even at this college and school where they're actually learning Java and trying out things. This will really create a new dimension of what will be done with the JVM. I mean, thinking about all these people doing stuff with LED strips on clothing and stuff, and then who knows, I probably would be doing that soon with Spring Boot instead of using C or whatever, and maybe people who will start using less Python for this, because it's now, thanks to all these other additions, making onboarding of new Java developers so easy without having to have a main class and explaining all that, and just writing a simple Java file and running it, and all the optimizations, getting the JVM to start quicker, etc. That there's no need to go back to the Python language, which, as we've seen, is not as green as Java is, whatever measurement that is. So this is really going to make it so much more interesting, and keep people on this language, and not which will be then the right language for further business development. I mean, people will either decide between the JVM or .NET, etc. But probably one day it will go away from Python, because you need something a bit more scalable and a bit more enterprisey, I think. And at least that's my feeling. Yeah.
The Spring team, the Java team, one of the core concepts we've been talking about, runtime efficiencies. One of the demos that my son is actually going to deliver later today is that we take our code that ran on Java 8 and then we switch it to Java 21, and the amount of memory that it takes is significantly less, like 40 or 50% less, just by switching to the new JVM. This goes back to the 32-bit conversation. If I can have the same infrastructure, if I can have the same devices, machinery, etc., that I've been using, we can still deploy and run the Java 1.0 code that we created back in the 90s. I could still be using the same Linux 1.0 that came, but we probably don't want to do that. We want to get all the benefits, the security, the performance. It'd be great to be able to have that same infrastructure in place wherever it's running, and be able to just upgrade in place. That would be wonderful. So there's definitely a need for that 32-bit approach. I'm on the same page with you, Pavel. But this runtime efficiency is going to open the door. It's going to make it easier. And I'm going to shout out to the Py4j Spring Boot Starter. It's going to make it easy for the whole, there's a few million Spring developers that I think also like Raspberry Pis and are interested in some of the cool things that they can do outside of the data center. I think we're trending in the right direction. And I think we're just getting started. I think the momentum is building. And it's conversations like this that I think are going to help it.
Right. So if we are talking about or thinking about runtime efficiency and Java, there are three main problems in Java to solve. First is startup time. It's runtime performance or throughput, and it's latencies and predictability of the Java execution. And there are projects in OpenJDK as the evolution of future Java, like Laden or Crack, for managing the startup time, and there are various approaches to managing and improve runtime performance, like various optimizations and compilation techniques and compilers, and there are some approaches to manage latencies that you're trying to manage today. Yeah, so I think that's all probably be the future and the bright future of Java on embedded, and not only on embedded devices, because we are talking about this pretty shady line between the enterprise and embedded use cases today. So.
And because we can use the same Java on all devices, the same runtime, different distributions, but they are available, we can benefit on all fronts of all these improvements. Okay. Thanks a lot all for your time. Thanks a lot for joining this podcast recording. The Py4j Spring Boot Starter that we mentioned, that will be available soon. We're working on that, DaShaun. And that will bring hopefully also a bit more electronics lovers into Java and vice versa, and we will see what the impact will be. Thanks a lot for joining this recording. Thank you also for listening. Keep an eye on FooJ for future articles and podcasts about development and everything related to the Java world. Thanks a lot.
Thank you so much.
Thanks so very much. Thanks.
Give me a foo, give me a J, give me the friends of OpenJDK.